Hey guys, welcome back. Today in day 3, part 3, we will go over string and characters in a very important subjects of Unicode, counting characters, accessing and modifying a string. Yeah, let's start our playground. So first of all, we'll go to Xcode and we say file new and playground blank one. Okay, let me go to my document and I have one directory here for learning. Yes, iOS, yeah, learn iOS Swift, and here it's all of my playground here. I had this one, yeah, okay, so I want to go string and characters. This is part 3. So I make this one. You can find it in comments as a link. Okay, and we can start our lecture now. Unicode. Okay, so let's go here and start. So Unicode is very important. I'm gonna read any single word here, any single paragraph, and discuss it with you folks. This is very important to understand Unicode in a string. If you do not understand Unicode, you do not understand string. But if you get a Unicode, then you will understand a string in the Swift, and you can play with the string pretty easy and comfortable because it's pretty modern language and give you international standards for encoding characters. So yeah, let's go over it and try it out. Listen this video as much as you can to understand any small trick here. Okay, Unicode is an international standards of encoding, representing, and processing text in different writing systems. So it's international, so it can you be expect gonna support any language. It enables you to represent almost any character from any language in a standardized form, and to read and write those characters to and from an external source such as text file or web page. Swift strings and characters types are fully Unicode compatible. So keep this in your mind. It could be one interview question as described in this section. Okay, so you need scalar values. So first we need to understand the unit scalar value. So behind the scene, Swift's native string type is built from Unicode scalar value. A Unicode scalar value is a unique 21-bit number for a character or modifier such as u plus 0061 for Latin small letter a, or u plus 1f425 for front facing baby chick, like this. Okay, so both of these will support, and you will see all of them support by Unicode scalar value like this. In just part in previous part we discussed how you can use this. Now it's detailed about that. Okay, note that not all 21-bit Unicode scalar value are assigned to a character. So this is important. Swift is pretty smart, so not gonna use all value for this. Some scalar are reserved for future assign or for use in UTF-16 encoding. Scalar value that have been assigned to a character typically also have a name, such as Latin small letter A and front facing baby chick in the example above. And now we learn extended Grapheme cluster. Okay, so every instance of Swift character type represent a single extended Grapheme cluster. So Not only it's gonna support this one, there is extended Grapheme cluster. So an extended Grapheme cluster is a sequence of one or more. This is very important, understanding this part. An extended Grapheme cluster is a sequence of one or more Unicode scalar that, when combined, produce a single human readable character. Okay, so what is that? Let's go over it. Here is an example. The letter E with accent can represent as a single Unicode scalar. Here we go. Latin small letter E with acute, or U plus 00E9. However, the same letter can also be represented as a pair of scalar. So it even could be pair of scalar values, not only one. A standard letter E, Latin small letter E, followed by combining acute accents scalar. So U plus 0301. The combining acute accent scalar is graphically applied to the scalar that precedes it. Turn an E into E with accent when it's rendered by Unicode aware text rendering system. So learn this. Unicode aware text rendering system. It's a rendering system and Swift that helped you to make one new letter with mixing, combining some others. So yeah, let's see. So far we don't have any text. Okay, here gonna start our first text for our playground. Okay, in both case, letter E is represented as a single Swift character. This is very important. So, Swift character value that represent an extended Grapheme cluster. So in the first case, the cluster contains a single scalar. In the second case, it's a cluster of two scalars. Here we go. So let's copy this, take it to our playground. The beautiful part of Swift that I love it. So here you go. So let's run this. Here you go. You will see both are the same. I want to just test it out. I say I just say E acute is equal, doesn't have, okay. E acute equal combine E acute. Let's see. This is true. You will see these are equal. But they are not. How come? Yes, they are equal because of the system, Unicode aware text rendering system. For Swift, they are both E. This is very, very useful. That helps support any language. Okay, extended Grapheme cluster are flexible way represent many complex script characters as a single character value. For example, Hangul symbols for the Korean alphabet can be represented as either a precomposed or decomposed sequence. Both, so precomposed or decomposed sequence. Both of the representation qualifying as a single character value in Swift. So here we go. So now we made that E without and with accent. Okay, now let's go for this part. So I'm gonna run this. You will see these two again are equal. So pre-compose equal decompose. Are they? Yes, they are. They are true. They are equal. Okay. So extended grapheme cluster. Yeah. So here you go. So we use just let talk about this more because I want to we get it completely. So here you will see we use this Unicode and D55C, and I made this Hangul symbol in Korean language. And here I made again, this is character as well. So I make one actually extended grapheme cluster by 3 of them. So this one plus this one plus this one, and totally these made same Hangul symbol, so they are equal. Okay, extended grapheme cluster enable Scholar for enclosing marks such as combining enclosing circle or U plus 20DD to enclose other Unicode Scholar as part of a single character value. So here we go. So this is another example to make this guy. So we mixed these two and we made this one, enclosing E acute is. So not only we made E acute, we made enclosed in circle. Okay, and another one, Unicode Scholar for regional indicator symbol can be combined in pairs to make a single character value, such as this combination of regional indicator symbol letter U and regional indicator symbol letter S. So we make these two together. What's gonna be output? Here we go. US flag. So this is how it's work, and you will see how wide is our it's in our hand to handle any character, any mixture characters, any something new coming. Even if we have some open spot in our Unicode with 21 bits, Unicode. Let's see exactly the same Scholar value. So this is how it is in string in Swift. Very modern, very useful. Okay, so far it's pretty awesome, but now we will have some trouble. Probably you can guess that. Yes, how we can count characters now? These two are one character, or two character. What is it? Here you go. To retrieve a count of the character value in a string, use the count property of a string. So we use count, and this one give us the number, counting characters. Sorry, here you go. So this will give us the number of the characters, and it will be exactly the number of the numbers of the characters. Doesn't matter, and and here this is one character. So if I add this one, just let me add this to the end, so it should be 41. So we learned how we can sorry, here you go. So let's now count it. It should be 41. Yeah, here you go. So this is 1. Okay. And so note that Swift used extended grapheme cluster for characters value. Means that the string concatenating and modification may not always affect a string's character count. Okay. For example, if you initialize a new string with 4 character cafe and then append combine acute accent to the end of the string, the result string will still have a character count 4. That's exactly true. So exactly I told you. Here we go. So we have cafe. This is 4, yeah? This is 4. And we have another one. This is 4 as well. Let's see. This is 4 as well. So let's see. I want to see that is these two equal or not. So yeah, yeah. Yeah, so I just say word is equal with word. Yeah, tell me that this is equal or not. So let's see if it's working. It's not working. It's say false. You may say why? It's supposed to be. If I want to get answer, let me try parentheses, because you know what? Because it's something that later we will learn. It will calculate this after, you know, so still false. So let me make here word 1 equal this guy. So now check word 1. Oh, yeah, here I need to say let's. Yeah, this is cafe, and are they equal? No, they are not. So this is interesting. So it says this cafe is not equal with this one. So this is a string cafe, but this is not. Oh yeah, sorry. No, it should be equal because we checked it out. So characters are equal, but words are not. Interesting. So this character is equal with this character, but the word is not equal. Okay, good test. Okay, so now we add them out, but you know, count is still 4. You know, so count of them is 4, because make that this you know, by adding that. Okay, so we got the result of this, and here extended grapheme cluster can be composed of multiple Unicode scholar. This means that different characters and different representation of the same character can require different amount of memory to store. So because of this, characters in Swift don't each take up the same amount of memory within a string's representation. As a result, the number of characters in a string can't be calculated without iterating through the string to determine its extended grapheme cluster boundaries. If you are working with particularly long string values, be aware that the count property must iterate over the Unicode scholar in the entire string in order to determine the characters for the string. So don't you know, it's just want to tell you that don't count for finding size of the string. Yeah, you know, well, yeah, the count of memory required for a string. The count of the characters returned by the count property isn't always the same as the length property of the ns string that contains, so ns string from Objective C. If you make a bridge, it contains same character, the length and its string based on the number of 16-bit code units within the string UTF-16 representation, and not number of Unicode extended grapheme cluster within the string. Okay, so we got it. Yes, it's pretty, and also we have a good test here about finding out, okay, this cafe is not equal with this cafe. You need to know that. So this guy is not equal with this guy. Okay, good to know. Okay, so accessing and modifying string. Okay, this is another problem. So now we handle counting with count dot, string dot counts. Okay, but what about the modifying that? Okay, so you access and modify a string through its method and property or by using subscript syntax. Okay, we'll go in substring next part. So a string indices. Each string value has associated index type. String dot index, which correspond to the position of each character in the string. Okay, so in other language we expect, okay, this is gonna be index, and you pretty easy with this subscript we can get it out, but no. As mentioned above, different characters can require different amount of memories to store. Okay, so in order to determine which character is at a particular position, you must iterate over each Unicode scholar from the start to end of the string. For this reason, Swift string can be indexed by integer. This is very important. Maybe in the interview they just give you, okay, I want to find index 5 of string. Don't go by, just directly put it there. No, you need to use handy property, methods available. So use a start index property to access the position of the first character. Okay, so for first, start index. The end index property is position after the last character. So end index for the position of the last. So if we wanted last, we should go one before end index. So end index is out of a string, okay? We'll go over that. As a result, the end index property isn't valid argument to a string subscript. Yes, if a string is empty, start and end are equal, about 0. Yeah, makes sense. You access the indices before and after given index using the index before. So you can go before and index after, and after your index. A method is methods of a string to access an index further away from the given index. You can use index underline the colon, semicolon, offset by, this can be integer method instead of calling one of these methods multiple times. So if instead of going several before, you can jump by offset by. Okay, you can subscript syntax to access the character at a particular string index. Here we go. So we have one test. So we have this. We won't go by anyone. So we will go by greeting start index. So gonna be G, yeah, capital G, and greeting dot index before greeting n index. So gonna be this guy, yeah. And here you go. So let's run it out. Yeah, greeting dot index after index, so second one, this U, yeah, and yeah, it is U. And this is if you want to go one by one, greeting dot index. Now this time we go by offset, so 7 after start index. So 7 after the start index gonna be this guy. Here you go. Okay, yeah, we make this, and okay, also I'm interested to know what is index type. Yeah, so I push option and click here. So it's a string.index. Type of it is a string.index. Let's see if I can print it. Print index for me. Here you are. So you will see output of index is this. you will see it couldn't be an integer. Yeah, it's an index. So type of this, let me option index, and it's string.index. So this is type of this. Okay, let me pull this out. We don't need this actually, just we will go by those handy ones. So attempting access an index outside the string, it will be runtime error. So yeah, here you go. Even compiler won't let you to move forward, so you'll get error in execution. Yeah, actually it's actually in runtime error. So you won't get error until you run it out. Okay, so yeah, for be able to move forward, I'm gonna comment this, and then later I'm gonna turn them back. Okay, so use indices property to access all of the indices individual characters. So if you want to get access to all of the characters, yeah, we'll go by this. And I use terminator, actually nothing, then it's not go, and next line gonna stay here. Okay, if I use backslash t, for example, as we learned just in the previous parts, it's gonna be a horizontal tab in between. Okay, let's run this and see what will be our output. Yeah, here you go, you will see it's backslash t. So if I put nothing, then here you go, it's gonna be like this. Okay, and I put a space here. If I don't put this, it's gonna write it down right there. Okay, so yeah, let's go. And yeah, here this is another one note. This note just say you can use start index, end index, index before and after method for a string. Also you can use for all collection types like array, dictionary, and sets. Actually next section gonna be, so we can use this for going through array, dictionary, and sets elements. Okay, inserting and removing. Okay, so I believe the last part of this, yes, it's inserting and removing. Okay, so the last question is how we can insert and how we can remove. It's easy as well. We have two method, insert and insert content of add, which help us to insert in our string. Here we go. So this one, hello, and then we will insert at welcome that end index at the end of it, one after, put this for me. Okay, so let's run this. You will see it's sitting there. But I want to put one there before this. So what I say, welcome insert content of at welcome index before welcome end index. Okay. So I just say before this. So this is welcoming. I just go one before and put this. You will see sitting here. Yeah, and this is for insert. What about the remove? So for remove, we have two other method, which is remove at. So remove at for me at this location, and remove subrange. So okay, so let's remove this one. So it's gonna remove at welcome index before welcome end index. So gonna remove this. Yeah, and here you will see how it's gonna be output of this. And so our welcome should be now hello there. And here I just say okay, range, I make a range. So make this range gonna be this operators that help us to make a range. So here a start of the range will be welcome index, welcome end index offset by -6. So 6 go before of the end, and welcome end index. So this is gonna be my range, and I say okay, remove that one. So 6 of this will go. So 1 2 3 4 5 6. So we'll have only hello. Yeah, there you go. This will be output of this. So this is how easy we can work with a string. And just the last one says that yes, you can use same methods of remove and insert, and even remove subrange and insert content of for all collections. So that's it for this part. In next part we will go over substring. Substring is a little bit different. First we will go about the difference, and then we will go how we can use it. It's was yeah, how we can use substrings to make new strings. Okay, that's it for today. I hope you like the video. If you like it, please make sure to give it thumbs up, and also don't forget to be subscribed for more video all coming every day. And if you have any question, please ask in comment below. I will be more than happy to help you and answer your questions. And I wish the best for you. Have a good one. Bye bye.